All right, so design for manufacturing and assembly. We've heard a little bit about this today. We heard Michael Mark speak about it earlier, and we also heard Skanska with Felipe. He was mentioning it, and where he really mentioned it was in and around the idea of industrialized construction, or in the UK here, what we call modern methods of construction. And really, as we start to look at the adoption of industrialized construction, or MMC, it becomes really essential that we start to embrace the DfMA approach. Now, what I want to talk about today is really the fact that it's more about data. It's more about the data. It's more about getting the right data in the right people's hands. It's about moving beyond the design for manufacturing and assembly and starting to move towards design for constructability. So really, as we start to talk about the data in and around manufacturing and assembly, how we can then take that and start to look at full project delivery and start to embrace design for constructability, understanding what we're actually designing and how it can be built. So, as I was introduced, I'm Joel Hutchines. I'm the VP and Head of Industrialized Construction at Slate Technologies. I've mentioned here that I was formerly the CEO and founder of Splash Modular, and that's where I want to sort of kick off, is a little bit about my background and where I started. So I actually started in carpentry and then moved into architecture, property development, and then really lately I moved into an industrialized construction and modern methods of construction, and really focused on how we can start to embrace or how we can adopt more of the off-site manufacturing methodologies. And that really comes down to this data for manufacturing and assembly. So really, when we're looking at how do we get manufacturing and supply data, and how do we get that in the hands of the designer, how do we help inform designers and empower designers to do a better job, that really takes it beyond that and into collaboration and starting to look at how we get the right data in the right people's hands at the right time. That's really where my career path has been really focused on, that and how that we can start to do that and how we can start to empower better design. And then that really led to computational design, digital fabrication equaling a productized process. So when we talk about this, we talk about off-site and we talk about manufacturing methodologies, where there's really a need to embrace digital fabrication. And a lot of this automation that we see in the manufacturing methodology means that then we then have to look at the productized process. We really have to start to look at how we do a better job of actually getting that, understanding what we're building, but also the process to getting it to the machinery. So digital fabrication, when we start to talk about embracing more digital fabrication, what we're seeing out there is a lot of these machines actually take different geometry, take a different approach, take a different actual knowledge to be able to design for them. And that was really when we started to look at computational design with Splash Modular, and how that we can leverage that to get early contractor involvement, how we can get in the hands of the designers or really inform design, but without actually having to go do it. So what we were seeing in the industry is a lot of industrialized construction or modern methods of construction suppliers were spending a lot of time trying to get in the room with the right people and help inform that. And then they were also having to reprocess that. So the efficiencies that they could gain through the machinery, they were actually losing when they were having to redesign the process all the way, or redesign the product or the project all the way through. This is where we came up with the idea of a customizable digital product. It was the idea that we could get all the collaborators in and we could create a product. And we called that a customizable digital product because, again, we're looking at the productized process. We weren't looking at a standard kit of parts or a standardized library of preconceived designs. We're looking at how we could leverage computational design to productize the process, and therefore we could issue a configurator or launch a configurator within native Revit or within design software to help architects or designers design within the realm of what's achievable. So it was really empowering them to have the knowledge base and the data at the outset so that they could do a better job of designing, but they weren't restricted to taking a library. They could really start to understand what they could do and push the boundaries within the realm of what's achievable. And that was where we got to. So we were with Splash Modular there. We started to look at the idea that we could create a marketplace for configurators, but it was all based around initially showing what we could do with a bathroom pod. So what we did was we built a computational design algorithm where we could take input, we could take the base outline of a bathroom, we could take the main elements within that bathroom, and we could create the full bathroom pod. So it was mainly about inputs and then outputs. But what we did was we took that approach and we boiled it down to the DfMA approach. So you can see here, what we did was we started to understand the CNC machining. So not only were we creating the design of the bathroom as a whole, we were starting to break that down into the elements as well. We could create the CNC files, We could lay that out. We could then look at how we were nesting that. So we're looking at the efficiency of the material. We're then starting to look at how, when you adapted that, if you moved it and scaled it, how that could automate the process. So if you moved the vanity, you'd update the CNC files. That would update the ledges, that would update the steel framing, that would update the plumbing. Everything was interrelated, and it would start to be completely autonomous. What that then allowed us to do was to really start to look at the efficiencies in how we were designing that. We were spending less time having to engage with the architects and with the GCs and educating everybody on how we were going to design it, and more on actually how we could actually create our product more efficient. So that was where we started to look at the nesting of that sheeting, and we could see that it was actually more effective for us to put a steel member and not to have all vertical sheeting. We could actually rotate it, and we could do what was necessary to get material efficiency. And then we could really look at the assembly as well and start to create ledges and details so that the assembly could follow. Now, this was the approach we built with Splash Modular, where we actually didn't manufacture the bathrooms ourselves. So we started to produce bathroom pods by licensing the assembly to somebody else and creating right the way down to the machine files for the steel framing for the CNC, that we could have a network of suppliers that we could actually just give the files to, and they weren't having to recreate the designs, and we created efficiency that way. So what we actually did was we productized the process again, and we were able to commoditize our design file and our design knowledge and our DfMA knowledge and create bathroom pods, making a clip of the ticket, but never actually building the bathrooms ourselves. Now fast forward to Slate. So recent news with the acquisition of Splash Modular by Slate Technologies. And what Slate Technologies is, as we've heard a little bit today, is the idea that we can build dynamic decision assistance for all stakeholders in construction. So as this process has evolved, I've really come on board and I've been focusing on how does that relate, but really first and foremost, it was understanding what is a digital assistant. What is this whole idea of how we can do that? And for me, the best analogy here is Waze. So if we look at Waze app, you put in where you're coming from, where you're going to go, and it calculates the best route. But what it then does is it's taking all the intersecting data points along that way and helping you guide you to the best path forward. So if there's an accident and it says that you think you're going to go left, actually it's going to say go right and go around the block because there's road work as well that you can't see. So all these other intersecting data points that you can't actually analyze or you don't understand, it's able to do that and guide you and keep you on track for the best way. So what we're doing at Slate is we're actually taking that approach and we're bringing that into construction. Now how does that relate to DfMA, industrialized construction, modern methods of construction? This is when we started to unpack it. There's no way in construction right now to help you identify, integrate, and manage industrialized construction solutions. So we're talking about DfMA, that's really about integration, but first and foremost, even understanding what you can identify, what is out there, and then how do you integrate, and then there's really no management or no database for how you can start to evolve that knowledge. So what we're focused on here is all that unseen intelligence, as I described with Waze. Now, how do we look at the correct quantified and unseen in terms of how you do start to create those decisions? And that comes down to really multi-criteria decision making. And so if we take the idea that you want to identify some industrialized construction opportunities, really first and foremost, you're going to probably look at the location. You're going to look at what suppliers are out there. But there's so many other factors that we need to start to take into account. The design intent, the cost, the quality, the project stage. Is the project too far along to justify adopting an industrialized construction solution, even though there is one? But then you want to layer in, there's a bunch more. There's a minimum order quantity. There's the customization. Can it be customized? There's the methodology that it's fitting into. Can we change the methodology to adjust for that? There's so many factors that we need to take into account. And that's even before we start to talk about whether we can integrate and whether it's actually suitable, whether those suppliers can perform. So if you start to looking at just making the decision about identifying or trying to look for an industrialized construction solution, there's so many other factors that we have to take into account for that. And that's really where Slate starts to come into its own. This idea of a decision assistant that can identify those solutions or opportunities for you. So you imagine a world where it's actually looking at that project and it's identifying that there is an option and it's quantifying that data in and around how that industrialized construction solution would work. Now that's the identifying aspect of it. But really when we talk about the integrating, I go back to the productized process. And this idea that we need to help suppliers through DfMA and through computational design and through digital fabrication to start to create these solutions so that they can actually, our system can start to help integrate them. So I'm going to show you a sample project here. This is a client that we're working with right now. who is actually a window wall supplier. And previously, the way that they worked, they would get design intent. They rarely receive it in 3D, in any 3D geometry. Occasionally they do, but most of the time they're looking at 2D, they're looking at the elevations, and they're going through and they're looking at what the design intent is. Here, they're actually having to trace over it and then go and optimize that and offer the best solution. So what they're able to do now, just through a DfMA logic, building a script, is that they can actually trace over the elements. So take the design intent, straight away create a higher level of detail model where you can go down to even to the tolerance, to taking into the design intent. But when this really becomes powerful is the idea that you've got multiple criteria here and you can actually analyze that. So you think of a scenario here where you've got the window wall supplier, the architect, the building owner, and the GC sitting in a room, and they're talking about this project and how to optimize that for this design. Obviously, the design intent's very important to the architect, but if we can then analyze that and give a little bit on design intent to optimize on standardization of panels or on material efficiency, now we can start to create the right, or get to the right level of detail, or find the best one. And what we're seeing in generative design is that we start to see multiple options here, but what we're trying to focus on is how we get to that one optimum solution, and then through the process of scripting and productized process, how they can then automate that. So here you're seeing the shop drawings are automatically produced, and now we start to then evolve that into how we create the higher LOD model, how we get to machinery level, how do we get to beyond that. And what this means is these guys are now able to go into that room, win that project, and spend less time on the early contractor involved in hand-holding, and then the process of recomputing that design. Now they can actually focus on how they can create a more efficient product. Where this then goes is design for constructability. So for me now, through that process and really looking at how we get the data in and DfMA, it's now become much more about design for constructability and the idea that we can get far more intelligence to the designer earlier in the process. So we can start to look at, yes, we have the manufacturing and we showed that, but now it's about project delivery. Now it's about all these other things that we spoke about, that Michael spoke about. What are the new materials? Does the supplier exist in that area based around that methodology? Does that supplier have the capabilities to do it? Is there other areas in terms of project delivery that didn't stack up? How can we actually start to get that right in the hands of the architect and help them to make informed decisions? So for Slate, that's really where it comes in and around the idea that the Slate system, it can see, it can hear, it can read, and it can predict. So it can take all of this project data, all of this data about delivery here in the project, and actually start to analyze that and offer suggestions. So you end up with implied and explicit opportunities or suggestions based off of all this data, just like I described with the Waze app, but now you're starting to drive that back into the full project. Where this then really circles back to the design for constructability is that what I originally called a customizable digital product or the productized process can now start to include chunks of work from a scheduling level. So now you can start to look at things at a task level in and around material, equipment, and labor and start to drive that intelligence over the project delivery, helping that to then inform design. So we can also populate from a design, so in that initial analysis tool where you're actually optimizing or optioneering, you can get it to the scheduling level, but then that goes right the way back around where we can start to actually drive some intelligence or offer some suggestions at the design level based off of previous project delivery. So that's really, again, where we start to look at, we can take designers, we can take design intent, and that can be a very basic design intent as we showed with 2D, it can be 3D. We can start to use CDP scripts or use these scripts to populate the work package, populate the task level. Now that's one value proposition from a supplier standpoint. Now they have a system where they can auto-estimate, they can actually use this, they can start to drive their own intelligence and build their product. But what that also allows us to do is to start to flick that back to the designer. So you have this, now that you have this idea that a designer can start to really receive key project supplier constructability data. So now you can really start to drive some value to the designer and help them to make informed decisions. That's where the DVA comes in. So what was originally the marketplace for configurators within Splash really evolved now to where we have a Revit plugin. The Revit plugin can actually start to look at scanning geometry, can understand what's being designed in Revit. It can help you then create, configure, and optimize, but then it can also automate. So now that you're getting the impact, you're getting that impact at the Revit level. So you can start to look at where design intent and really start to drive the change, and then that can really inform and help everything downstream. So I'll finish up there that it's more about design for constructability. It's about empowering the designer, and it's really about providing the correct, quantified, and unseen contextual data before, during, and after every decision. So I'll open it up for questions.
We've got a little extra time for Joel. Questions? Excellent topic.
Not all at once.
Yeah. I know it's the end of the day. Does your solution sit as a plugin on top of Revit?
Yeah, so currently the Revit plugin sits in Revit as a plugin in Revit. And then what we're able to do is extract that data out of there based around that design intent and process that. And really then a lot of the intelligence still sits within the Slate system so that we can bring that back around. The reason that we do deploy it in Revit is just it's the native tool of what people are using. Mm-hmm. So it is really just about getting that back in the hands of the designers. More and more, we do have the capabilities within Slate right now that you can bring in models and you can do the exact same thing within Slate. And you can do that. That's where you can do the 2D PDF tracing. Yeah. But yeah, again, as we drive more intelligence in and around those systems, it is getting it in the hands of as early as possible.
Excellent. So the future may be to bring data in from other sources.
We can do that already. Yeah. So within Slate, we can import those file types and then process that geometry there generic. As well. Yep.
Excellent. Other thoughts and questions? I know it's towards the end. Oh, we've got a question in the back here. Hang on one sec.
Just on the step from Slate into manufacturing, how does that work?
Here, hang on a second.
So I was just wondering what the step from Slate into the manufacturing process was. How do you interface with equipment? How do you have standard libraries for different products for like the window frames and things like that, like Shuko or whatever?
Yeah, so it's supply specific right now as we're building those scripts. So again, we're going in and we're building that logic, building that script, and that's where we can automate that entire process. So that's where we can get to the G code. That's where we can get to all of that within the script. So there is no need to pull that back out and go into a third-party CAD/CAM software or anything like that. We're actually able to productize that process so much within the script that the output is automated. And that's really the beauty here is when you've got design intent, so you've got geometry coming in from different design intent, you can automate that process all the way through, alleviating that need to continually redesign things. And then that's, closing the circle, closing that loop, bringing it back. Now you can start to really understand design intent, but then help to optimize and optioneer that as well within Slate. So,
thank you.
Good question. Any other questions for Joel? I've got one more. You talked about at the beginning around toilets, kitchens. How far do things scale? I mean, those were great examples because they are sophisticated. You move one thing, everything else needs to be changed.
Yeah.
Are you able to scale up? How far can you scale up? Like a whole home?
Yeah, for sure. So yeah, I think Michael mentioned earlier that people are starting to productize full building typologies, right? So if you think of it as a multi-family project or a single family home, I think that yes, as you can build that script, it's still based around the idea that it's sub-assemblies or multi-trade assemblies, single trade assemblies, components and raw materials. So as you scale that up through those different typologies, then yeah, for sure you can get the full building as a product at that level. What that then enables you, and there are some people in the industry starting to do that, that enables you then, you can imagine at a point of sale for a single family home, that level of customization where even the consumer can have that idea. Or if you take that to the other level, you could start to have a kit of parts, and then you can look at generative design and some of these options of what people are doing, and you can actually start to populate that with real buildable components. And now you're going to have an intelligent system that can really scale. So for sure, start small, but you can go all the way up to a full building.
Massively configurable.
Yeah, exactly.
That's wonderful. Joel, thank you so much. Michael, thank you so much.